So what I'm going to present to you is the specific pitch we gave to Unilever. And I'm also going to explain how this product can also relate to the Rolls-Royce challenge. What I want to get across to you is how we're addressing both of these challenges through a very similar approach, and one which can be productized and can make a very big impact across many different manufacturing sectors. I would say I'm focusing in this case on the Unilever problem, because as a company, this is our first focus area: process industries, consumer goods. So first of all, who are we? Myself, Alex, and Bashir sat over there. I come from a manufacturing background, and I've spent 10 years or so in manufacturing, mostly aerospace, actually. And building this product comes from a frustration that I had running a process which I couldn't quite get to grips with, and it kept going wrong. And for me, it was a black magic, but the truth is all of the data correlated to the answers. It's just a physical system. Bashir comes from a software and electrical background, and also a deep learning background. So he's previously had a medical image analysis startup. We built the business so far through a few very good accelerators: Entrepreneur First, who are pre-seed funders for us, and also IoT Tribe, based out of Barnsley, who we're currently with, who are sat in the audience here. Thank you very much, guys. And we're in the process of closing seed investment. So we're a very small company now, 3 people, but in a few months' time, we'll be growing the team towards 10 people. So we're very much building a product that we can support all big companies with. So we're building a product that uses AI to learn physical features in a manufacturing process. What you see on the right is a real-time animation of an example we have. This is time series data, predicting, using actually 56 different process variables from inside a factory, flow rates, set points, process variables, to predict an outcome in real time. And that's kind of the foundation of our product. Basically, we're able to very accurately model the physics of a system without actually knowing anything really about the physics. Now, for me, as a manufacturing engineer and a mechanical engineer, this is a bit crazy. But as you've also just related to this machine learning technology, it introduces a whole new angle to these areas. So for me, when I first saw actually the first work that Bashir had done to demonstrate our technology, I kind of had, wow, like we didn't even tell it how long the pipes were or what was going on. So this technology is able to predict phases and predict cycles within systems. So that could be meteorological cycles. So in some gas networks, there are spikes at 9 o'clock in the morning, 5 o'clock in the afternoon. Typical classical PID systems and control systems don't really account for those. This system can, and it sits on top of that. It can learn complex relationships. So in the case of, in fact, for Unilever, this is particularly important because you might have 200 different time series data streams. You might only have 5 labeled sets or 6 labeled sets, which is quite a sparse data, but actually there's a very high dimensionality of that data through the 200. So it can learn those relationships, and it can continuously adapt. So over time, it can continue to learn. Now for us, what was really important is we're building a product. We're not coming at this from a consultancy perspective. So looking at each of these problems, for us, we were thinking about how does this fit into our roadmap? We want to be able to build it into the product and actually support it through the lifetime with our customers, not as a kind of one-off build. So we're using this core technology to actually build what we call a pro tool for engineers, which can be applied to a wide range of applications. As I say, at the moment, we're focused on process engineering. And actually, our vision is automated real-time optimization. So using that information to fine-tune in real time set points and control variables. So this challenge actually for us really fit quite nicely into the process phase identification as part of this pro tool. Because actually it's a common problem not just for Unilever, but for many of the customers we're already starting to work with as well. So why process phase identification? Well, we've all spoken to Unilever in this session, so I guess we have an initial understanding. But for me, what's particularly important is if you want to get towards real-time live identification of the variables and optimization, this is a challenge that needs to be addressed. And it needs to be addressed in a real-time data stream as well to get optimum results. So the scale of problem, I think this is, Adam, you probably don't mind me saying, it's probably quite a secret problem. If you don't exist in this area, people don't necessarily know that it's a problem to segment phases. But it's actually a very broad problem. So for Unilever, it's actually applicable in almost all of your processing lines. And if you imagine over 200 hairlines around the world, just hairlines, and many of them are legacy, and they're all different, you can't formulate economically a physical model for each one of these. You need a scalable approach. And for me, it was quite an insight to see that take about 1 man day to actually segment one data stream. And so if you're trying to segment 300, that's probably about a year's worth of work. So we developed a mock-up of the dashboard that we proposed to build. So we did this last night and kind of thought about what the work stream would be like and how this would fit into the flow. So the workflow to start with is actually to connect with the data, configure the data, train the model. In this pitch, I'm not really going into the detail of that model in particular. I'm really focused on the product side of it, but train the model, get the inference from the model, and then export those phases. So it's quite straightforward, but that's how we've built the mock-up, is really to reflect on those different phases. And the strength of this approach is scalability. So any different product line, any different factory. It's data efficient. Now, this is something that we really have to prove through the first actions is if you're only labeling 5 or 6 different sets, what is the confidence level you can achieve with that? And at this point, it's not possible to say, but we think because of the dimensionality of the data, it can be quite efficient. Identify the phases, and as I say, presenting this as a self-service SaaS tool, so just the software. So we presented what our project plan is, and as I say, that is how we propose to make a very big change, not just in Unilever and consumer goods, but if you can start to imagine how a discrete manufacturing factory like Rolls-Royce is now starting to collect more and more data, you can actually start to imagine that more as a time series data set, more as an interconnected process data flow. So it's all about the digital thread from start to finish. And for me, although the process industries are the beginning point, they're the kind of early adopters. And I think if we look to where the rest of discrete manufacturing is going, they're going to follow Rolls-Royce's lead. And so I think this technology is going to be very important. And to be able to put these tools into the domain experts' hands, not just in the the data sciences' hands, is a real big challenge. And that's one that we're taking on. Thank you.